not sure if you heard me then, but I used a new tool and all the slides are now loaded into Meet Echo, which is kind of nice. So we don't have to share our screen. We can just select the deck we want from that icon from second from the left, right next to the hand. And what I don't know is if people can drive their own slides, if we need to drive that for them using this method.
Seeing if I go to meeting materials, like the fifth from the left, like the folder thing, I see the agenda slides, I think, and then I see 2 other presentations, but not all of them.
Well, if you go to the on the right by your name, if you click on the folded paper looking thing between the hand and the screen, if you click on that, you should see all the slides. I'm going to stop this and let you do it. You click on that, and I just loaded everything. Everything is sitting there to select. If it doesn't work for you, don't stress, because it's working for me. And
taken. I guess I need to let's see if I remove yours. Okay, now let me try. That looks great. So,
but they're not. I don't think
does
they're
it
sharing
mean
right
that
now, are they?
you can share and then you can actually do other stuff sort of in the meantime, or I don't know. Do you want me to share and you take notes again, or how do we do this?
Sure, let's do that. But right now I can't see your shared slides. I don't know if anybody else
I'm
can.
not seeing anything either, guys.
Try to share the agenda.
But I think it, yeah, exactly. Yeah, there you go. That works good. So yeah, you do that. If you've got that figured out, then choose those. And I'll take notes, but the reality is I'm just going to go back and watch the video later and take notes. And you and I are just going to be talking over each other since you're half duplex. Why don't you go ahead, Stig? Start us off.
See my slide, or?
Yeah. Yes, we see your slide.
Looks like. Okay, I got it. I just had to change the presentation view. Okay, so shall I start us off then and go through the status slides?
Yes. Yes.
So I'll start, and if you want me to stop speaking, if anyone else wants to talk or anything, just wave at me. Okay, great. Okay, so welcome everyone to IETF111 PIM working group. It's not a good time for many people, or it's a great time for some people, as usual. But yeah, thanks to those who made it here. We got quite a few people. That's great. All right, so yeah, Mike and I are the chairs. If you forget what we look like, there's some photos here where you can see Mike's camera. There's a note well, so it's the usual slide. I hope you all know this. All right, then we have the agenda, which looks like this. Pretty full agenda. So we got a request from Torless to present a bit earlier, so we're gonna move the last presentation before Anush's presentation. Does the agenda look good otherwise? All right, so let's go to the working group status. So basically, we're going to look mostly at the drafts that are working group drafts. We have the PIM-Yang model. It's been sitting in the queue for 3 years or so, I think, the RFC editor's queue. Looks like all the references are sorted now from what I see. I think it should be published very soon now. Then we have the IGMP-MLD Snooping Yang model that has been in the queue for a long time too, but not quite as long. So hopefully that will be published soon as well. Then we got the point-to-point multicast BFD, multi-point BFD. That, yeah, we requested publishing for that a while ago. The AD Alvaro has reviewed it, had some comments, and the authors are working on revising the document and addressing the comments. So hopefully that will move forward soon as well. We requested publication for the IGMP MLD extension draft. So that was kind of recently, so we haven't heard back from our AD yet regarding that. Then we have the DR improvement, and we also have this backup DR draft. So the story now is that we have adopted the Mankamana and BDR draft as well, but that doesn't mean that we will necessarily publish both those drafts as RFCs eventually. We need to figure out in the working group what do you want to do. Do we need both solutions or not? Do we need 2 drafts or not? Just open questions here, but those are some other things we need to figure out. But we're not going to discuss that today. We are waiting for the authors to publish new drafts. So hopefully next IETF, we will have a lot of discussion about various DR solutions. Then we have null register packing. So we needed more review in the working group, and we got a couple of volunteers that reviewed it, and we had some discussion on the list, which is great. But we're waiting for the authors to address all the comments. So a little bit slow going here, but hopefully we can make progress soon. But thanks a lot for those that volunteered and reviewed the draft. Then we have IGMP-MLD proxy Yang model that we will discuss today. A third packing draft was revised and presented. Oh no, not presented, but anyway, it was revised in June, but not presented this meeting. Yeah, all right, comment from Mike.
Yeah, so I think, and I think I saw Yisong on this call. So I think I'm on this draft. I think we are ready for working group last call. Yisong, if you're there, could you confirm whether you agree with that? Or Sandy?
You hear me?
Yes.
Yeah. We have discussed in the with some co-authors, and we think that the draft is stable, and we think we want to request a last call.
Great, thank you. That's what I thought. So Stig, after this IETF, we will ask you to do that on the list, please.
Yeah, that sounds good. Yeah, if there's anyone in the room, I was going to say, if there's anyone listening that have any concerns about doing a last call, please let me know now or bring it up on the mailing list. All right. Yeah, I can see at least personally, I reviewed the draft. I think I had like one minor comment, but it looks pretty good. And yeah, I think maybe my comment actually has been incorporated already. I'll check that later. All right. Then we have some other drafts. We have the SR point-to-point multi-point point-to-multipoint policy. And we'll have some discussion today related to that. Then finally, we are moving ahead with progressing IGMP and MLD RFCs to internet standards. Basically, yeah, IGMP version 3 and MLD version 2. So we will discuss that today. There's also this other really old RFC for host extensions for multicasting that also we probably want to revise, and then we will discuss that later today as well. So yeah, that's what we had for the status. Yeah, if there's any comments, let me know, or please speak up. All right, the last thing we had is charter update. So we have been we started doing some SR point-to-multipoint work in PIM, and we already had adopted that draft. So that was discussed with routing IDs and Spring chairs, and we agree that that work could be done in PIM. And in general, we might want to do some more work in PIM in this area, but if we do, it would be in close collaboration with Spring to figure out, where is the best place to do the work. But we thought it would be good to formalize this a little bit and at least add some text to the charter. Mike, maybe you can comment on this.
So I think we've done this well from the beginning when we first adopted this draft. And before we adopted that draft, we worked very closely with the Spring Working Group, waiting for the replication segment draft to be adopted. And then we adopted this draft per Spring's desire. They just don't have time for multicast. They don't want to deal with it. And they even just told us last week that, yep, you guys got it. We're not going to recharter. We probably don't need a new working group. Let's just go ahead and just make this formal and just add a sentence into the PIM charter just to make it formal. So we have proposed text. There could be a better way to word this, but this is what we are planning to add. Whatever we decide to add, we will run this by the Spring Working Group, and then before we officially add this to our charter. It may be good to hear some thoughts from the working group on whether they have different feelings or if they think there's better wording. Yes, go ahead, Hillman. Hillman? Can't hear you. Try again later if you can get your audio working.
Yeah, you need to click on the mic icon, I guess, to actually speak.
He's going to try again, he said on chat, so just keep going. Okay, I'm going to go ahead and remove him from the queue. Anybody else? Okay, so I say we'll send this to the list, maybe just as we have it here, and we'll take the discussion from there. Once we come to a consensus, then we'll send it to the Spring Working Group for their opinions, and then if it's all agreed upon, we'll recharter.
Oman, I see you got the microphone, but yeah, I guess it didn't work. Okay.
No, it didn't. So let's move on.
I wish I was the only one with audio trouble. Yeah. Okay, so I guess that's what we had for the status slides. Yeah, I'm gonna mute myself here now, but yeah, I guess we are ready to start on the first presentation then, or
Yeah, so Stig, why don't you just keep driving to the slide? Yeah, just choose Hongji's slide now, and it should work good. And if so, Hongji, you're up.
Hi, Mike. Can you hear me?
Can hear you fine, just can't see the slides yet. Can you?
Yes, I can hear you. I saw a new deck is being shared.
Yeah,
Stig, are you
that's what I got.
sharing the slides?
There we go.
Okay.
It's all you.
Okay.
Hit it.
just tell me,
No.
when we go to the next slide. I went to number 2 here. I hope that's okay, or let me know.
Okay. Now this is number 2. Okay. It's okay. Now let me introduce some updates about the IGMP MLD proxy YAML model. This is the version file for this draft. We have updated this draft according to young daughter's comments and other comments. The next slide, please. Okay, thank you. Update 1 is the filter mode leaf as a mandatory leaf. This leaf contains enumeration, include or exclude. In the old this leaf is not the mandatory leaf. Here we set this one as a mandatory leaf now. Next one. Next slide, please. Okay, update 2. We changed the in the IGMP proxy tree. We changed the type of the group address from the IPv4 address into the IPv4 multicast group address, and this new type is also used in the IGMP YAML model. Next, please. Similarly, we also changed the type of group address from IPv6 address into IPv6 multicast group address in the MLD proxy tree. This new type is also used in the MLD YAML model. Okay, and next, please. Update 3. According to the young daughter's comments, we update the prefix of this YAML model from MMP into the IGMP MLD proxy. The IMP is the abbreviation of the IGMP MLD proxy. We think the full name is more clear. Next, please. Okay, here are all the updates about the latest version. Next up, we would like to apply for the workgroup last call, and we welcome more comments. Thank you. That's all.
Question here. Did we do a young doctor review of this? I don't remember right now, to be honest.
Yes, the young doctor have reviewed it about maybe 2 months ago. We have already addressed all the comments from the young model, from the young doctor.
So that worked out okay. There are no major issues.
Yes, he said most of this most of this draft is okay. Just some needs, and we have list all the comments from the young daughter.
Great. So I think we are ready for a working group last call. If anybody feels otherwise, please speak up now. Okay, thank you, Sanji. I think we're good. And if Human hasn't figured out his audio yet, we may need to move to Stig.
Now?
Oh yeah,
Hello?
we can hear you.
Okay. I had to change PC. I don't know why. The other one is giving me so much trouble.
Yeah, it's fun.
Okay, thank you. So next slide, please. So nothing much has changed when it comes to the different drafts for point-to-multipoint policy. The status code is the same. At the PSEP, we did change some aspects of that draft to fit the PCE controller method better. And we are again asking for adaptation into 112. The chair was liking our way going forward, so hopefully that's going to work out. And in the IDR, we did present the point-to-multipoint policy, and we did ask for adaptation in IDR and in BESS. So this is obviously the transport tunnel technology. So we weren't sure whether it's going to fit in BESS or whether in IDR. So that's one thing we need to figure out, where is the home for it, which one of those working group is the home for it. Probably it's going to end up in IDR, but we'll see. And last but not least is this ping policy. And just to give you folks a little bit of background, since this entire technology is from controller point of view, and there is no signaling. So when it comes to detecting data path failure, we could either use like mtrace type of technology that goes over the VPRN that would test the two ends of the two PEs or the CEs, and not the transport tunnel itself. Or we need to have a technology like the point-to-multipoint ping that would test the tree itself. Next slide, please. So just a little bit of memory refresher here. So this kind of will remind you what we are trying to do here. So on the head end node, there is a point-to-multipoint policy that has a set of candidate paths. One candidate path is the active candidate path, and the remaining candidate paths are backup candidate paths, if you will. Under the candidate path, there is usually two path instances. The path instance is the tree itself. It's the point-to-multipoint LSP itself, where the forwarding instructions, or what we call AKA replication seeds, are associated with. So again, the forwarding instructions are associated with the path instances, and the reason for that is that we were hoping to achieve global revertive behavior or global optimization. And so that's why we have two path instances under each candidate path. So If there is optimization done from the PCE perspective, it's gonna nail down a second tree with its own replication segments, forwarding instructions, and then it can do a make before break on the head end to this backup tree. And obviously, for this to work, that means that the receivers, the leaf PEs, they need to listen to both path instances. So while there are traffic on the fly, on the previously active one, you process them, and then you can also process the traffic, new traffic that is going over the new path instance that is optimized. So this draft is trying to test the path instances for each candidate path end to end. So it should be able to identify each path instance for each candidate path and test it end to end. Another point I want to just bring up is that previously we mentioned that two replication segments could be disjoint from each other, could be connected via unicast SR policy, whether it's MPLS or SRv6, beside the point. So there could be a unicast SR policy that connects the two replication seats, and in that case, the replication seat, the label itself, is at the bottom of the stack. So in that case, in this draft, we are really not testing the unicast domain. So we are just testing the replication points where the replication segments are. Again, we can definitely talk about it and see whether we need to test the unicast domain, and if so, how do we want to achieve that? But as of now, that the way that the draft is, it just decrements at the replication segment. It just decrements the TTL. It pushes on the unicast label, whether those unicast labels are going to be pipe mode or I forgot the name of the other mode, the one that uniform mode. Beside the point, but if the TTL in the unicast domain expires, as of now, the draft is not testing that. It is not able to detect that. Next slide, please. So we try to reuse a bunch of RFCs that are out there. Obviously, RFC 4379, just for the packet construction. And then there is RFC 6425, which is the MPLS extensions. That RFC is for both LDP and point-to-multipoint RSVPTE. Reading that RFC, we felt that LDP procedures, they fit very nicely with the point-to-multipoint policy. So we didn't try to reinvent the wheel, but that doesn't mean that if the working group start reading these RFCs and they felt some part of it doesn't fit nicely, we cannot modify or add. So that's exactly why we are here. So the only thing that we really added here is two new sub-TLVs that identify the IPv4, point-to-multipoint policy for IPv4 and for IPv6. So these two sub-TLVs, I think it's in the next slide. So the reason I said, by the way, IPv4 and IPv6, those are the root addresses. Again, if there's a better name for it, we are all ears. I know probably right now that I read it, I kind of realized that it might be a little bit misleading because the point-to-multipoint policy is really MPLS or SRv6. But the reason that we call it IPv4 and IPv6 was because it identifies the root ID of the point-to-multipoint policy, where really that's the root ID, the tree ID, and the path instance are the unique identifiers that that identify the replication segment at each hop. So that was the reason behind the naming. Again, if we feel that that's not good, by all means we can change it. But as I explained, the identifier now is the root address, the tree ID, and the path instance, and that's how we can identify the replication segments. And if the TTL expired based on whether it's a trace or a PIM, we use the procedures in the previous RFC to reply back to the header. Next slide, please. Yeah, so there should be a bulletin that says, questions, comments, please. We are all ears, and based on the feedback, we are hoping to eventually adopt this in this working group.
Thank you. Go ahead, Jinguang. You have a question.
Hello. Thanks, Howman, for the sharing. I have a question. Do you have the packet format of the P2MP policy pin packet? Is the UDP port needed?
Do we need a UDP port? Again, those part of it we left in par with the previous RFC that we coded. I forgot what it was, 64, whatever it was. So all those parts are explained in that RFC. Let me put it this way. When it comes to the data path itself, really a point-to-multipoint policy is very much in par with the point-to-multipoint LDP. I know some people might not agree, but basically all it is a label in, and then you got a bunch of outgoing interfaces, and you swap the label with the next replication segment, and you shoot the packet out, the OIF. So when it comes to the data path, if your data path supports MPLS or MLDP, point-to-multipoint is very easy to program your data path because it's exactly the same. So that's why we didn't feel when it comes to the procedures, they need to be any different whatsoever than what is inside that draft, which again, I keep forgetting, 6475, I think it was. I don't know whether that answers your question or not, but yeah, that's my summary of it.
Okay, thank you. I think you got to the point that this question is about the PIM packet, PIM data packet, which may include encapsulate the PIM echo request or echo reply in UDP, first in UDP and then in IP and then in the Talo header. So there is a problem about what the UDP port and what the IP destination address used. Of course, you can use the same as things like MLDP pin or LDP LSP pin, but I suggest this can be checked.
Yeah, for sure. Let's take it to the working group. Yeah, definitely. Maybe there's something that we are missing. Obviously, we need to fix that. Sorry, just to make sure I understand. Are you talking about the mtrace v2 that the UDP the UDP port is falling in the Linux trace route? Is that what you mean, or I wasn't quite sure what you mean by the PIM UDP? But anyway, we can take it to the working group. We are all ears.
Okay. I will follow up in the mailing list. Okay.
Okay. Thank you. Yeah, definitely send us a message there. We can definitely discuss it further over there.
Since there's nobody else in the queue, so Hooman, it seems like the reason that you're proposing this is because the existing echo request and reply mechanisms for segment routing don't work for point-to-multipoint. And is that correct? Is that why you're doing this?
Yes, exactly. Because so when it comes to point-to-multipoint, you need to have the procedure to fan out your trace route or your echo request, which again, yeah, the segment routing stuff doesn't fit very nicely here.
Right. Okay. And so you need to do similar. You have to do similar things for protocols, and that's why you're doing similar proposals in other working groups. Correct?
Yeah. So exactly. So we feel that the procedures again are very much closer to MLDP or point-to-end multi-point RSVPT LSPs. The segment routing is unicast that like, let me put it this way: if this was ingress replication, somehow this was ingress replication, then we could have used segment routing procedures to test each one of those unicast paths from head end to the end. So we can actually say that, hey, I want to test leaf 1 or leaf 2 and send the ping to that specific leaf. But if you want to go on to the head end and send a single packet and make sure that every single leaf replies to that packet, the unicast SR stuff is not working. The procedures there are not sufficient enough to make this happen. So this is why the MLDP point-to-multipoint LSP's procedures are more in line with the point-to-multipoint policy rather than the unicast SR.
That makes sense. I'm going to go ahead and start a poll right now. We'll take this to the list, but let's just get an initial idea of how people feel about adopting this draft.
Yes. So can I ask though? By the way, I think my audio is working now without my headset. Have you presented this to Spring as well, or do you believe it belongs in PIM rather than in Spring?
No, I have not presented to the Spring. If the chairs feel that we should present this to the Spring, by all means, we could do that. But no, I have not.
Okay. Yeah, no, we can check, if there's interest in PIM in adopting it, and if there is, then we'll have that discussion with the Spring chairs, whether they feel that's all right or not.
Okay, sure, no problem.
Yeah, I think that makes sense. The difficulty is never trying to get time to present in Spring, so that's why people, with regards to Spring and point-to-multipoint, they present here, which makes sense. But I agree. So right now we have 7 people who have raised their hand to support this. Nobody against it yet. We will take it to a list, and if we are in agreement, then I think, Stig, the point you're making is that we should then just copy the Spring working group, say, hey, this is what we're planning to adopt, and do you have any feelings otherwise? We'll probably need to do this at all related drafts, related to segment routing.
Yeah, right.
So yeah, okay, very good, thank you.
That was my next question that I was trying to ask. My question was that it's great that this working group is taking on, point-to-multipoint segment routing and stuff. But how would this group approach with the Spring? Is this something that we still need the blessing of a Spring by presenting it there? But if they bless, then the main work is going to be done here, or is the blessing with this working group itself? Again, I'm open either way. I just want to understand.
Yeah, my feeling is that we don't, after we recharter particularly, we don't need their blessing anymore. But we have agreed to keep well coordinated with them, and particularly when it involves the replication segment, which they do own and which this draft seems to affect. So we definitely need to be coordinated with them, and if they do object, well, yeah. Right.
So typically, if there's kind of overlap, it is pretty common to present drafts in multiple working groups. So even if the Spring chairs, say that, okay, sure, this is better to do in PIM, you might still want the work to also be discussed in Spring just to see that, it makes sense there. Because there might be participants in Spring that don't come to PIM and so on.
Thank you.
But yeah, we'll see what the Spring chairs say, you know, whether they feel it needs review in Spring first or whether we can go ahead.
What we typically do, Human and everybody else, is after our meeting, we just ping the chairs of Spring and just say, hey, this is what we've done. We're planning to adopt this. Please yell if you have any major concerns. Otherwise, we're just going to keep going. It will change a bit, like I said, when we officially update our charter, but we'll still give them that courtesy.
Okay, understood. Thank you.
Thank you.
All right, so I believe I'm next, and yeah, I'm not using my headset now, so this should hopefully be working okay. I can hear if anyone is saying anything. Yeah, this draft was presented in Lisp on Wednesday, by the way. So we believe that the work belongs in the PIM working group. But since it's about Lisp, we want the Lisp working group to make sure that it works from Lisp perspective. And at least after my presentation in Lisp, they seem to be okay with their work being done in PIM. All right, so last IETF, the first version, like version 0 of this draft was presented. And one of the things that were discussed previously was whether it makes sense to define a new TLV, like a new joint prune attribute, or whether to reuse an existing attribute. So after some discussion about this, I'll get back to that. At least the authors, well, including myself now, believe it is fine to reuse the existing attribute. I'll get back to that on the next slide. So the use case is basically doing Lisp multicast. So you have like Lisp sites that have multicast, and you want connectivity between the sites. Between the sites, it can be like a unicast network. So you do head-on replication, like just unicast replication between the sites. Or you can try to do multicast between the sites to just have, you know, like normal run PIM and have multicast replication in the core. So there is this RFC that we did here in PIM 6831 that defines some joint prune attributes for Lisp signaling. So basically, the way it works is you join through the core to establish a multicast tree in the core if necessary, if it's multicast in the core. But you also need to somehow signal between the Lisp border routers to say what you actually want to receive, right? It's encapsulation, and the signal in the core would be just for the underlay group. But we need to signal and say what do we actually want to receive over the underlay. So so there's two ways of using this today. With unicast in the core, you send this join message, and using 6831, you say that I want unicast replication, and I want this destination address to be for the unicast packets, right, for the encapsulation. But you can also use this RFC to say, I want to receive by multicast. The problem, though, is when you receive a multicast, there's no way today to say which group do you want to encapsulate this in. 6831 doesn't define that. So what we are saying in this draft is that the existing joint prune attribute in 6831, we want to reuse that for specifying a group address for the underlay. So there's deployments today using Lisp multicast in the core. but the group address is just hard-coded by configuration or whatever. There's no way of signaling this. But we would like to have this flexibility where the receiving side can signal and specify the group address. There's various use cases where you might want to have different, maybe have two different endcaps for the same group. Two different flows, S1G and S2G, for instance, might, even though it's the same group in the overlay, we might want to use separate groups in the underlay. But yeah, the main thing is to just have this flexibility. This slide is maybe not that useful, but it kind of shows what I was just talking about, where we in this use case have regular IP multicast in the core. And so the signaling we're talking about in this draft is basically joins that are going over the top directly between the B routers, like B2 to B1 or B3 to B1, to say what multicast do we want to receive. And that is, as I said, in addition to the underlay signaling in the core. So 8059 is defining this RLOC attribute. And it says in 8059, it says receiver RLOC. And as I said, that's like the destination address that you want to encapsulate to when you do unicast in the core. So what you want to do in this draft, or what is specified in this draft, is basically saying that we can reuse this receiver RLOC attribute to specify a multicast group address. The concern about doing this was like backwards compatibility. But at least as far as we can tell, existing implementations that do multicast in the core, they would never look at this receiver RLOC, right? Because that's specifically specified to be used for unicast. So if you try to reuse this now, existing implementations should ignore it. Only new implementations that support multicast in the core and this new draft would actually go and look at this attribute. All right, so let's see. Yeah, so yeah, I'm presenting this as an author, and I would like to ask the working group and the chairs whether this can be adopted, and also if there's any comments in the working group.
Nobody's in the queue, so I'm just going to go ahead. So there's already a Lisp multicast distribution tree specified in Lisp, including defining PIM join prune attribute extensions and things like that to construct the tree. So this document extends this to facilitate the construction of underlay multicast. So are you also proposing the mapping between the underlay and the overlay in this draft? I didn't catch that. Is this
okay? So what happens is, let's say if I go back to this slide here. So you see here I'm talking about, for instance, like S1GO, right, where G is in the overlay. So that's like some source inside a Lisp site is sending, say, to S1GO. And in the underlay, we just send a join for, say, like the group GU1 or something, right? Because that's in the outer header. So what we want to do, or what we do with this signaling, is basically there is this Lisp, PIM join sent as unicast from one Lisp border router to another, and saying I want to receive S1GO. What is new here is that when we send that join to say we want to receive S1GO, we also can specify, oh, by the way, I want it to be encapsulated inside GU1 or GU2.
okay?
So looking at this slide here, right? If the source is inside site 1 sending to S1GO, you want, say, a join to be sent from by unicast from B2 to B1, saying I want to receive S1GO. Then we want B2 to be able to say I want you to use GU for NCAP in the core. So the only thing new we're saying here is we use this existing alloc attribute to say what we want the underlay group to be. So you can say for unicast, you're specifying the outer destination address, right, which is a unicast address. And what we want for multicast is the same. We want to specify the outer destination. It's just that it happens to be a group address since it's multicast.
Okay, and do you want us to pull the working group right now? Or
yeah, that would be great. Okay. So, but yeah, just to clarify, so all we are doing here is to relax what this one attribute can be used for.
Okay, so the poll is out. We'll see if we get any response, and we will also take it to the list. Any questions for Stig before we move on to the next presentation? All right, so we have 6 people who are in favor, none against. So we will ask the list as well. Thank you for doing that. And let's talk IGMP MLD extension source management. Is it pronounced Huanan? Huanan Lee, China Mobile. Go ahead and unmute yourself.
Hi, PIM experts. I am Huanan Li from China Telecom. I'm going to introduce our draft. Its name is IGMP extension, IGMP MLD extension for multicast source management. Next page, please. First, I will introduce why we propose these extensions and procedures. Then I will introduce newly defined messages for IGMP and MLD. Next page, thank you. Among protocols for IP multicast, there is no interaction protocol between multicast sources and routers so far. The interaction between a multicast source and the router is triggered by the multicast source sending packets to multicast group, which is tightly coupled with the multicast data. In this way, multicast sources cannot be well managed, especially in large-scale multicast service scenario. In addition, the multicast source is unaware of receivers. The multicast source may continuously send multicast data when there is no multicast receiver in the group, resulting in a waste of resource. We specify some new messages to extend IGMP version 3 and MLD version 2 for exchanging source registration information and data transmission control information between sources and routers. In this way, the transmission of multicast source data can be effectively controlled, enhancing the security and controllability of the multicast service. We will introduce our solution in combination with the beer multicast management signaling process based on PCEP between routers. In the figure on this page, step 1 to step 10 are the processes of the overall solution, where step 1, step 4, step 8, and step 10 are the related processes of multicast source management. Step 1, source, Step 1, source a newly defined multicast source registration message into to ingress router requesting to activate the multicast data transmission service. Step 2, ingress router sends the request information to the controller. Step 3, the controller feeds back the authentication results. Step 4, ingress router sends authentication result to the source where newly defined multicast source registration message. If the authentication succeeds, the multicast source waits for the router to notify it to send data. Step 5, receivers send IGMP or MLD messages to egress routers requesting to join or leave a SG. Step 6, egress routers send these requests to controller. Step 7, controller informs the egress router start or stop forwarding. Step 8, ingresses routers ingress router sends newly defined multicast data allocation message to source to notify the source starting or stopping sending multicast packets to the group. Step 9. Then the source starts or stops sending multicast packets. Step 10. Ingress router periodically sends newly defined multicast receiver status message to the source to synchronize statistics of receivers. Next page, thank you. Then I will introduce these messages. First, the multicast source registration message called MSR message is used for the registration and registration of multicast sources, as well as the corresponding response. Flag I bit indicates whether the sender of the message is the source. Flag R bit indicates whether the action of the message is a multicast service request. Flag A bit indicates whether the request is successful. Credential is used for authorization of multicast sources. Timestamps are used to indicate the duration of the service request. Next page, please. The multicast data notification message called MDN message is sent by router to notify multicast source to start or stop sending multicast packets for different SG tuples. The router needs to send multiple MDN messages. Flag C bit indicates whether to start sending multicast packets. Sorry, I made a mistake here. Next page, thank you. Next page, please. The multicast receiver status message called MRS message is sent by router to multicast source to synchronize receiver statistics of a group of multicast group for different SE tuples. The router needs to send multiple MRS messages. Next page, thank you. That's main content of this draft. Any comment on our draft, on our work are welcome. Thank you.
Yeah, speaking as a working group participant, I think this is pretty interesting. There was a draft presented or discussed in the Magma working group very long time ago that also did like a source registration thing. And there was a draft I presented in PIM like 10 years ago, like magma-m-snip that also talked about this. So yeah, I think it could be interesting. There's lots of problems in multicast related to source discovery, and for instance, with regular PIM, right, we do like data registers. If we had something like this, we could send just a null register, for instance, and have the RP join the shortest path tree to the source before the source starts sending. The only concern really I see is that it's tricky to get hosts to be upgraded to support new signaling. That's the main problem I see. Otherwise, it looks quite interesting to me.
Yeah, likewise. I don't remember the Magma discussions on this, but I think it is pretty clever to. Oh, here goes Brian. He remembers. Go ahead.
Yeah, you guys just dust off all the old good stuff. Yeah, so MSNP was designed around the premise that you wanted to minimize sources sending data when there were no receivers actually listening, and it would essentially it would help control the extraneous flow of data, especially when you're talking about a rendezvous point that was potentially far away. With some of the drawbacks, and this may be a question for the authors, MSNP was designed with SSM in mind, and it really did not have support for ASM. So the question would be, do they intend to support both modes of distribution, or is this really just focused solely on beer? So there is some history here. There was talk of a request to send, clear to send kind of methodology for IGMP way back, I think in the IDMR working group as well. So I would encourage people who are interested in this topic to kind of dig into the archives to see what kinds of things they might learn from previous attempts to do something similar for multicast.
Yeah, I'll be happy to comment on the mailing list with some pointers to drafts and some comments.
Thank you, Juanan. I think we're good. Do you? I guess we just would take this to the list. There doesn't seem to be a request for an adoption at this time. So yeah, okay.
Hello, Chaz. Do you hear me?
Yes. Go ahead, please. Thank you.
Okay, this is Wei Changcheng from China Mobile, and I will give you some presentation for this draft. At the beginning, I think this draft we don't intend to involve in some specific solutions. The only purpose for the draft is to provide some observation and consideration on our new requirements. So next page. In this page, I want to present some new requirements and potential use case for the broadcast. Now, firstly, the networks are changing. The application and the websites support IPv6 better and better. The operators network have already support IPv6 very well. So the IPv6 traffic are rapidly growing. So from my point of view, the pure IPv6 network will be used in the near future. And secondly, there are a lot of new application scenarios for the broadcast, which bring some new opportunities. Here, I would like to talk about more on the OTT live video.
Sorry, Weiqiang. Mike, I think this maybe go to the next page.
Yeah, the wrong page. Okay.
So let me know whenever we're on the wrong slide.
I just look my local. Okay, so I just mentioned the first factor is networking are changing. The IPv6 network will be used. The pure IPv6 network will be used soon. And the second factor is that there are some new opportunity for the broadcasting, and I would like to talk more about the OTT live video. Example, I would like to introduce. So on this Thursday, a new record of OTT live video was generated. I don't know if you know, there is a very famous Chinese pop singer and movie star named Andy Lau, and on this Thursday, he had a online live show for his 40 years career on the Douyin application, which is a TikTok for Chinese version. The number of online viewers even more than 100 million at the same time. I think it's a believable record. So you know, on the at the same time on the Douyin application, there are 100,000 similar personal live video show is ongoing. So the problem for operator is that there is no any cast technology used for such a huge amount traffic, because the operator's network cannot sense the multicast traffic. This also generates a very big traffic burst to the operator's network. So how we can handle that? That is a problem. Let's summarize the key requirement for this kind of service. Maybe a person that can be a multicast source, and you know, there are a huge number of those kind of multicast sources. The second is a large number of online viewers. As I just mentioned, this example I just mentioned, even over 100 million, they just for one person live show. And for operators, I think there is a big opportunity is that we provide the multicast service. Maybe I want to see multicast service as a multicast as a service is a potential big market for operators. So I think this is some new requirement for multicasting, and maybe we can consider service-oriented multicast technology for IPv6 network, and it's time we can consider some new way for that situation. Next page. Okay, so let's go back to the existing network. We know such as a PIM, that is a traditional multicast solution. It requires the multicast tree, which building on a control plane. And there are some new solutions, source routing based, such as beer. It reduced the state of the nodes, and it can simplify the deployment and maintenance. I think both of them are good, but as I just mentioned, those solutions cannot support the service-oriented application scenario. So is that possible for us to consider IPv6 and multicast and source routing to develop, combine them together to develop some new solution, which can be used better for the service-oriented application scenario. If that is possible for operator, we can provide multicast as a service. So next page. So here are some consideration on, we call that MSR6, IPv6 multicast for source routing. Here are some basic list. That just some initial draft. Please comment that. The first one is we hope this kind of a solution can support basic multicast functions such as P2MP forwarding, multicast flow overlay, P2MP OM functions. And secondly, we hope those kind of a solution can meet the need of high quality services. The service I just mentioned maybe need a high reliability. So in order to achieve that, the solution should support traffic engineering and some fine-grained granular network measurement. And the next page. HL. Next page. Yeah. So the third requirement may be we hope the existing solutions can be reused as much as possible, such as a beer. We think that is a very good solution, and maybe include SRv6 because including channel mobile, more and more operators begin to develop SRv6 So we think maybe we can consider SF6 also. And the existing and ongoing IPv6 extension. So next page. Okay, here a summary. We just write name MSR6. We hope that can have following characteristics. The first one is a native IPv6 design to reduce the header layers, and the second one is reuse the existing IPv6 and SIV6 capability, and the third one is beer maybe is a good multicast mechanism, and the fourth is MVP and traffic management, traffic engineering should be required. But anyway, all those requirements should support the service-oriented multicasting. So we write a proposal that maybe now is the right time to consider new multicast mechanism for those new requirements. So that's all. Thank you. Any comments?
Thank you. Any questions? If not, my comment is, so I did read the draft. It appears that you're not proposing any particular protocol solution, but you're raising the question of, given segment routing, particularly SRv6, and requirements with regards to traffic engineering, and maybe even DetNet related kind of information, you're suggesting that maybe it's time to consider a new solution beyond what we have today, and maybe that includes certain elements that we have today, like beer and PIM, maybe even PIM. But so do I have that correct?
Yeah, I think that is the basic content in current draft. But I think we really met some problems for the multicasting. As a use case I just mentioned. In fact, it's a huge opportunity for multicasting. If we can provide multicast as a service to those OTT provider, I think that is a very good, very strong driven strings to deploy some new type multicasting solutions. I think we need that. We hope community can consider those kind of requirement. Maybe we can generate some new protocol or new solutions for those requirements. Thank you.
Yeah, I think it's interesting to analyze, what are the use cases, see what can we do with what we have today, and basically what is missing, what can't we do today. It could be good to present this in MBOMD as well, because they are focusing more on the use of multicast to see, whether they have additional use cases or comments on these use cases. While in the PIM working group, we would more see, do we have any solutions, or should we work on solutions for those problems?
Mm-hmm. Thank you.
Yeah, good comment, William, in the chat. So yeah, I would encourage you to take Stig's advice and also to maybe bring this up on the mailing list, the PIM mailing list, as well as MBOMD, and let's have further discussion. Thank you. particularly
Thank you.
being that we're getting this proposed from a operator. That's, for us, that's golden. That's fantastic, because we hear plenty from vendors, so it's nice to hear from operators. Thank you.
Thank you.
Hello, can you hear me? Hello?
Yes, go ahead.
Oh, okay. Okay, this is Zhenmin from Huawei. So this is a quick introduction about the gap analysis of the IPv6 multicast source routing. Okay, next page. Okay, so we have this brief introduction about MSR6, then the gap analysis and summary. Okay, next page. Okay, since the design consideration has been introduced by Wei Qiang, so here is just a quick glance on the MSR6. So this is for the MSR scope for the best effort service, traffic engineering service, and overlay service, including the MVP. And also we have this the reliability and OEM. And we also need to take into account combining with other IPv6 based functionalities, including the network slice, IOM, alternative marking, APN, etc. So, and also this is try to take use of the existing solutions as much as possible. Okay, next page. Okay, so here these are the possible solutions. This is the beer in 6. So that's the keep the beer as an independent layer. So that's is the possible solutions for the existing solution. So this is the gap analysis as follows. So that is not designed for the native IPv6. That means it can also support the non-native IPv6 scenarios. Second one, so that's if for the IPv6 source routing. So there are some the architecture concerns. The first one is the beer is treated as an independent layer. So the existing, how to support the existing IPv6 features. So these possible IPv6 features include the fragment security, network slicing, DataNet, etc. So this to that's deploy to define the new encapsulators in the beer layer or not. So that's the first one. The second one, so that's if the beer is treated as a separate layer, but the rest of the functionalities are realized in the IP layers, there's also some challenges. For example, if encryption is supported in the IPv6 data plane, so it makes the content of the beer layer encrypted and unprocessable. So this also needs to be taken into account. So the third one as the introduction from the Wei Qiang. So that's we think about that's the IPv6 multicast source routing at the host. So that's this also if the BRN6 is used for the source routing as the host side. So the beer layer will have the conflict with the transport layer, including the TCP and the UDP. So that's and also the source address of this the packet of the packet originated by the host may be also changed. So that's also the challenges. So that's the others that's need to maintain the tunnel state. And the last one, so that's existing functionality. So that's the BRIN6 should be extended to support the MVP, traffic engineering, and the IPv6 existing features, including fragmentation and ESP. Okay, next one. So this is a gap analysis of the BRV6. BRV6 is to encapsulate the beer in the IPv6 extension header. So this is a native IPv6 solution. So it can reuse the IPv6 functionalities. So it can also use the native IPv6 and initiate the source routing as a host side. And the BRV6 also has the following challenges. The first one is the non-MPLS beer header defined, but the beer header is designed as a separate layer. So that leaves some fields unused and redundant in IPv6. Second one, so that's the BRV6 also needs to be extended to support MVP and traffic engineering. Okay, next page.
Comment
From
here.
Greg, you're able to take it. Go ahead, Greg.
Mm.
You got a question, Greg?
I recall that in the beer working group, these two proposals received very extensive discussion. I don't really understand what is the purpose of continuing this discussion in a PIM group.
Okay, so this is not only the beer discussion, this is discuss the gap analysis of these solutions for the IPv6 multicast source routing.
But your analysis seems to be one-sided.
Okay, I have to learn the other side.
Yes, so basically you provide position of one of the side that was in a discussion in a beer working group. So I don't really see this gap analysis as unbiased analysis. You are promoting single solution.
Okay, so I think that's if you have this one, this can be go on to be discussed in the mailing list because this is beer. I think now that's used for the best effort service, but we also have the traffic engineering work to be done for the IPv6 source routing.
But why not to have this discussion in a beer working group? Why to take it outside of beer working group? That's what I wonder.
But this maybe for the traffic engineering work has nothing with the beer.
Why? For example, we do have beer TE architecture in a beer group proposal. So traffic engineering in beer, in my understanding, is very much in the scope of beer working group.
Okay, so this is because you know that some of this work is in the PIM working group to use the routing header to encapsulate the multicast tree based on the SRv6 segment. So I think this work is related with the SRv6. So we think this should be discussed in the PIM working group.
Well, definitely that is something that working group chairs can decide, but I really wonder why you bring the beer discussion to the PIM working group without discussing it in a beer working group.
I think
I'm personally very much surprised. Thank you.
Okay. Okay. So that's depend on the solution. Okay. Okay, next page. Okay, so this is a summary. So I think that's the existing multicast solutions are not sufficient for multicast source routing to support future potential multicast use cases. So we think this is the right time to expect a new multicast solution. And also is just as discussed with Greg, because this work related with Spring, Beer, and IPv6. So that's we think that work has multiple involved parties. So here we just thinking about this to be done in the PIM working group, Spring working group, or new working group. So this is depend on the coordination of the different working group. Okay, comments, please.
Go ahead, Rick.
I think, like the previous draft, we're presenting here a problem or an issue that needs to be addressed, and so I think the MBON group should be also where this should be also discussed or presented, right? So, what's the evolution of routing for given the amount of traffic, et cetera, and so that should be where the MBON group should be, where this should be discussed, in my opinion. Thanks.
Okay, thanks. Okay, go, Greg.
I'm surprised that in the list of the working groups you don't mention beer working group, but I would strongly encourage you to bring this and discuss it in a beer working group, because my understanding is that beer technology solution is absolutely capable addressing most of issues that you identified here. And as I noted, traffic engineering already has an architecture document that being progressed, and if I understand correctly, it's in ISG review. So there is a solution, the proposal, how to address it, and you can look at it and see. And that solution can coexist as a domain with what can be characterized as a classic beer and traffic engineered there. So again, please bring this discussion to the beer working group.
Okay, thanks for your suggestion. We'll take it into account.
Thank you. So I think the takeaway then is to continue this discussion in MBOND, in PIM, in beer, and in maybe Spring, since it's very SRv6 heavy, and and we'll go from there.
Yeah, this touches on a lot of working groups, but yeah, a lot of this has been discussed pretty intensively in beer. So I certainly think that this needs to be discussed further in beer as well. Basically, a lot of these gaps are like beer specific, and it would be good to get analysis done in beer to see whether these gaps are there, or if there's ways of solving it with beer, or whether it can't be done with existing beer.
Okay, we can
Great.
go on, have the more gap analysis, and also later present this work in the beer working group. Okay.
Great. Thanks again.
Yeah, thank you.
Let's move to Torres.
All right, you're sharing the slides for me, great. Okay, next slide. Okay, so the goal, this is part of updating the core PIMS standards that we started with IGMP, and so this one includes IGMP v1, which we need to retire. So we need to obsolete 11.12, but basically keep everything except for IGMP-v1. And the main issue is this is also the only and the most, basic core standard for multicast. It's full IETF standard, so we'll need to figure out how to manage the process that this can go back immediately to full standard. There's going to be no functional changes of either what's kind of functionally written or what I think is actually implemented. And I think we'll take Alvaro's advice as we walk along. Next slide. So this is what I did for the 0.0 draft. Admittedly, it's all the simple stuff. I removed the IGMP-v1 section and text referring to it. So that gets the main thing done. I added references to v2, IGMP-v3 and MLD-v2. Those, I think, would be replaced with references to the drafts that are meant to supersede them, so that, ultimately we'll have a big cluster coming out together, all pointing to the right, documents referential to each other. I added text to make this apply equally to v6. Obviously, this was written when there was no v6 in '89, and there is no existing IPv6 document that would do anything similar, right? So there is some text in 8504, but that doesn't really capture what this document does. And I also added text to say, well, this is now also called ASM, and references to the SSM documents that we have, so that we also unconfuse people that have seen, ASM only being referred to as IP multicast in quote this document, which is the Bible for, ASM. Next slide. So now we're getting to the tougher parts. So this predates also the RFC 2119 and later language with must, should, and so on. And so I'm not even sure if it would be possible these days with all the IETF politics to simply keep the text as it is without starting to change small letter must to large letter must and so on. Would love to hear input from Alvaro on that one. If we even have the option, but maybe we do actually want to do this. So trying to find the places where requirements have to be capitalized is one of the tasks I wanted to take on anyhow. Next slide. Okay, so what is 11.12 actually normative for, right? Because people think it's just the API to the applications, and we haven't standardized APIs to the applications outside of TAP's working group so fairly recently. It is actually the protocol part of the host stack of IP multicast without routing. Send and receive multicast actually has 3 levels defined, right? So no multicast, only allows sending of multicast, which kind of in '89 was something you got for free. You didn't have to do anything for it. And then level 2, which is what we today perceive as multicast, which is sending and receiving multicast. Right, so it is normative on the wire behavior, not explained in any other RFC. And so if we were asked for adoption of RFC 11.12, I'd basically ask the counter question. So, show me a single system that does TCP/IP that doesn't implement level 2 IP multicast. Because, for example, in IPv6, it's even mandatory for basic discovery, right? This is not multicast routing. This is multicast host step, right? So 0 and 1, more questionable. I'd like to keep them. I think that's going to be an interesting discussion. There are going to be crazy issues that might come. So next slide. So what was actually the biggest normative issue with this host stack, right? So, and that was really that we had packets with the unicast destination address, but source addresses in the multicast range. Those perfectly well resulted in denial of service attacks in a distributed fashion with the unicast destination returning a multicast packet with ICMP port unreachable or something like that. And that, of course, is correctly written as you must drop these packets in 11.12, but 11.12 was never mandated anyplace else, so a lot of implementations didn't do it. We fixed most of it in the early 2000s. But it is not today a mandatory update for 791 IPv4. Obviously, there is nothing even equal for v6. So I think one of the things is that this document will need to end up being a mandatory update for RFC 791 and 8200 or 8504. Still need to figure that out. So that basically these very simple things about there are multicast addresses, there are multicast packets, and there are multicast addresses, and what you do with packets of either shape, the ones that are multicast packets and the one that are just crap. So, and 1112 already says this fine, but needs to be mandated. Next slide. So yeah, so it's meant to obsolete 1112. There is a bunch of other strange text in 8504 I've started to look into that doesn't look too good. So for the matter of time, we're running out of it. I'm going to skip over this, just captured it for my own notes here for the update, for the next update. Next slide. Actually, these bad packets with multicast source addresses, they should also be dropped on forwarders. This isn't necessarily going to describe all multicast forwarding. There is no really good RFC at all that says what every multicast forwarder should do. But this one piece, I think we can sneak in there to really make sure these packets, even in IPv6, are never going to cause issues. Next slide. Yep. So then the not so fun stuff. So we have the situation that a lot of these core documents were written by Steve Deering, including 8200. Where he also didn't edit anything, and Bob Hinton was doing that for him. And after 8200 was finished, and that was fine, the IETF process put some more hurdles into it, like you cannot submit any draft without email addresses for every of the authors, and Steve Deering doesn't want to have his email address published, and authors actually are not the ones who are editors, but the one who are responsible for the content, right? And obviously it's still the same content, even if we change the wording from Steve. So Alvaro already discussed this in the ISG. Thank you very much. So hopefully that piece we're going to figure out. There's also the question of copyright, of transfer of copyright, which isn't implicit by old documents that happen also in the late 90s, early 2000s. So yeah, fun administrative stuff. So that's pretty much it. So I think next slide, the plan will be, please start engaging in that. I'll try to bug the IGMP Biz design team meeting with the work that I'm doing. Co-authors for this one also welcome, and hopefully it'll be in a shape to ask for working group adoption by IETF111 in November. And that's it.
Thank you. Brian.
Hey, Torles. I'm almost wondering if what this document needs to become is something similar to the scoped addressing architecture document for V6. I think what we need to be able to capture is those broader pictures that you were discussing, and I think 1112 is a good starting point. But there's a bunch of other things that we would need to pull in, which will allow you to capture some of those relationships between 791 and the various IPv6 documents as well. So we may need to think about this as being a slightly bigger project than just where we've started.
Well, let's discuss this. So far, I haven't seen anything that I would feel, worried about asking to simply keep the BIS as a full internet standard like 1112 is, because there's really no functional scope change other than the obvious one, which is the same applies to IPv6, and all this stuff has been working perfectly well, unless somebody ignores these simple, send and receive packets from the host stack, like we've seen in V4. I haven't tracked a lot of that in V6, obviously. In the one vendor where we had the problem with V4, we fixed it also for V6 immediately, so it didn't show up independently. At that point in time in the early 2000s, there wasn't much V6, but if you can see now a lot more vendors in IoT and other spaces, implementing maybe even only V6. So yeah, bring it up, please. Let's hopefully have this follow-up discussion on the design team. I don't know what other stuff beyond the scope. I hope I can get the stuff moved into the PIM-WG GitHub, Mike, when you're listening to this, right? So that we can start putting also issues up there so that we can track these things.
Any other questions for Torles? Otherwise, we need to move on to the final
Unfortunately, need to leave. I have my third presentation this slot, so but I'll watch the recording. Thank you.
Thanks for joining, and you look good. See ya. All right, let's talk 3810 and 3376.
Hi, am I audible? Hello. Am I audible? Yeah, thank you. Good afternoon and good evening, everyone. My name is Anuj, and I'll be presenting on the behalf of the team working on advancing IGMP v3 and MLD v2 to a full internet standard. Instead of taking separately about both IGMP v3 and MLD v2 draft updates, I'll be presenting the update together through one slide deck, which is shown here. Next slide, please. Yeah, so this work started some time back, first with preparing a survey containing a set of questions about the implementation status of the different versions of IGMP and MLD. It also had questions about the implementation specifics and the implementation perspective of the vendor. So different vendors participated in the survey. Later, survey results were captured in a report, and they were also published in a draft. So currently, team focused on developing the zeroth versions of RFC 3376 for IGMPv3 and RFC 3810 for MLDv2. So main idea was to focus on the criteria to make these RFCs full standard. So primary focus was to assess and incorporate valid errata, also to identify if there are any other potential changes needs to be done in these documents. Some of those changes could be like consolidating the work done on IGMP v3 and MLDv2 via some other documents. Let's say, for example, RFC 4604 is one of them. So as objective here is to make these RFCs full standard. So what we have to make sure that there shouldn't be any optimizations done in terms of protocol exchange and all. Changes should be more in line to make them a full internet standard. So if there are any unclear parts of the RFCs that should be explained in a better way, it could be either like parts which were unclear during implementations or leading to making some assumptions while doing these implementations by vendors or like host implementations. So changes should be done to remove parts of the RFCs which were not used by any vendors or any implementations. So initial versions of these documents are published with valid errata and can be accessed by these links which are there present. Most of the content of zeroth version, these BIS versions for 3376 and 3810 are borrowed from RFC 3376 and 3810. So it would be better like if we use the diff tools to see the differences for those people who are already well aware of the RFCs and have been gone through them many times. All the issues which we worked on or which are currently also present, like open issues, they are all tracked by the GitHub. And if working group has any issues which they wish to report, so they can use the GitHub. Next slide, please. Yeah. So we have, instead of talking about all the things, so we have picked a representative issue on which teams spent a good amount of time. So this is an existing errata against the definition of older version query present timeout in RFC 3376. So the older version query interval is the timeout for transitioning a host back to IGMP v3 mode once an older version query is heard on the web. So the problem here is the referenced variables in the definition are not even available to the listening host. So we looked at the 3 sampled implementations and they do not use the formula originally mentioned in the RFC 3376. So keeping the criteria of like full standard in mind, full internet standard in mind, like interoperability and consistency between the implementations. So we updated the definition text so that it could be clear for the new implementers, as well as definition text was updated to reference values available to host, and they were more aligned with the information found in old query messages. Clear justification for this definition is provided in the BIS document, why they were required in the first place at all. And now definition is like more aligned with what is implemented and what is used in operation. So what remaining item would be like carrying this definition over to the from 3376 BIS to 3810 BIS MLDV2 for the consistency. Next slide, please. Yeah, so what would be the next steps that needs to be done? It would be like going through the remaining issues which are documented on GitHub and all other issues which are going to be reported. So all those issues should be considered, and few other things would be like discussing with the working group and the AD for the status of the older versions of IGMP and MLD, like RFC 1112 IGMP v1, 2236 IGMP v2, and 2710 for MLD v1. So what should be the status for them? Should be moved them to historic, or they should still be marked as obsoleted in the new standard? And like we would be looking for a working group adoption going forward. Any questions and comments? That would be all from my side.
Thank you. And Stig, you've been driving this, so I'm going to let you continue to do so.
Right. So I don't know if we should do a poll, but I'm assuming that there's good support in the working group for trying to make our core RFCs, IGMP v3 and MLDV2 full standard. And the way to do that is by writing these BIS documents that we have started on here. So I guess the main question is whether the working group thinks they are of sufficient quality to adopt now, or whether it's better to wait. I don't have a strong feeling on that, whether to adopt now or wait. Yeah, Brian?
Well, since Mike likes to use the hand raise tool, I would at least be interested in whether or not people in the working group are supportive of the direction that we're taking with these documents.
Done.
Thank you.
Hitoshi?
I agree on the work group adoption, but what do you think about the relation with lightweight version of IGMP v3 and MLD v2? Because there is no discussion about it.
Brian?
Hitoshi, I'm not exactly sure I understood your question. Could you ask it again?
Because there is no discussion about relation with lightweight version of IGMP v3 and MLD v2. The RFC number is RFC 5790. That is also a proposed standard, and I don't know. I'm sorry, but I only attended a few meetings of the design team meeting, and I couldn't follow everything of the discussion inside the design team meeting. But if we can exclude the explicit mode operation, then you also need to refer the RFC 5790 because lightweight version IGMP MLDB2 are pretty much simple, and it's easy to implement in a host side and router side implementation. So so I don't know what kind of discussion happened in the design team meeting related to a lightweight version and exclude mode operation and so on.
Yeah, so most of this, all the sessions I attended, we did not discuss the relationship with the lightweight versions, and I think those are valid issues to add to the issue tracker so that we can actually look at that. Because part of what we have to decide, and the slides allude to it a little bit with, what do we want to do with the actual older versions of IGMP and MLD? Are they just simply going to be, obsoleted by this new draft, or are we actually going to move them to historic? And there's all sorts of administrative things that kind of go along with that. I don't see any reason why we can't add the lightweight RFCs to that list for consideration of how we want to handle them in relation to these new documents.
Okay. So my question is that if the aim of this standardization is just for fixing the errata, I also want to say maybe we can just exclude the unneeded functions from the full spec mode. So maybe this kind of discussion could be valuable. So this is just my comment. Thank you.
Thanks for the question, Toshi. That's a good thing for us to consider.
Thank you.
Yeah, and for what it's worth, Brian, we've had 6 people in support of adopting and none against, so we'll, of course, follow up on the list with this, and I'm confident that it will be adopted. They will be adopted. Any other questions, comments about this or anything else we've talked about today? We're nearing the end.
Yeah, I can maybe add that if anyone wants to join the design team, it's open for all. I mean, we're looking for volunteers, and if there's someone else that hasn't volunteered yet, welcome to join us. But yeah, I guess we are done then.
Yeah, thank you. We'll see you in Madrid, or not. I don't know.
Yeah, we'll see. Yeah, oh, that would be great.
Thank you all.
All right.
Have a good weekend. See ya.